Hello, welcome to our presentation. My name is Damlatıcı Şimşek. Firstly, let's start with the question why we need a music library. As we know, the music industry is getting bigger every day. The variety of music increases with every song that's released. These days, with social media, people can access music much more easier. Music has a big part of our lives and it is indispensable. It is making our lives more livable, especially in quarantine. So what should we do? Of course, we have to make this our advantage. But how? First, I will talk about our goals. Our aim to be a highly visited website with new singers and songs. We are planning to have a very large data and information with various songs and artists. So basically, we will be everything that you expect from a music library. With this website, people will be able to find numerous information about music. And let's talk about our requirements for the website. Of course, our users will be able to access our website freely. Users can get information about singers, their albums, and songs, such as release day of the song or total sales of the album. By registering in our website, users can rate the songs, can add a new artist to our website, or change the title of the song, and also can list all the songs of the artist and much more feature. Our website will be flexible and updated. It is kind of similar to Wikipedia system, but of course you have to register first to use those features. So where does the data come from? We are making a lot of research to get the most reliable information. We are using the internet and social media most of the time. Gathering those data together will make it easier for the user to find the information they want. We will make sure to have every song and artist in the world. These days, anyone can release a song and get popular. Even you can come up with a song, and if you do that, we will make sure that you are on our website. So let's look at the anomalized data of our system. This is our anomalized table. In here we have singer information, album information, and song information. Let's look at the attributes. We have singer ID, stage name, real name, age, gender, birthday, death day, birthplace, nationality, marriage status, website of the artist, information, genres which they usually use, occupation, label, total album sale, and studio albums. These were the singer information. For the album information, we have album ID, album title, number of tracks, total duration of the album, tracks, album release day, total sale of the album. Let's look at the song information. We have song ID, of course, title of the song, duration, type, songwriter, producer, release day of the song, link of the music video, and song award. We know that not every song have award, but we wanted to include that in our information. Let's look at the users table. We have 5 example users, and for the attributes we have user ID, username, user surname, user email, and user password. Let's look at the user rate table. In here we have users, songs, and their rates of the song. Users can rate 0 to 5 and we will get its average. Thank you for listening. Now my friend Özgür will present.
Hello everyone, my name is Özgür Baltacı and today I'm going to talk about normalization part. Firstly, in our main data, you can see singer ID and dependent variable names, for example, stage name, real name, etc. And we create singer info table and all dependent columns are in it. And after we create it, we drop related columns from our main database. And then you can also see here album ID and dependent variables are, for example, album title, number of tracks, etc. And in order to reduce data, we created album info table and all dependent columns in it. And after we create it, we drop these columns which are dependent on album ID. And here you can see song ID and their variable, for example, title, duration, type, etc. And in order to reduce our data, we created singer info table and all dependent columns in it. And after we do that, we drop dependent columns from our main table. After we do all, our main data will be reduced to singer ID, album ID, and song ID, which are all primary key. Then we have user rate table, and you can see username and user surname is dependent on user ID, and title is dependent on song ID. In order to prevent this, we dropped user name, surname, and song title, like here. Here. Then when we want to go back to our original data, we execute this SQL query, and when we run this, you can see our main data here. And now my friend Dennis will continue with the ER diagram. Thank you for listening.
Hi, my name is Dennis, and this is the ER diagram of our database. As you can see, we have 5 different entity tables. 3 of the tables are related to the singer, album, or song you are searching about. The remaining 2 are related to the users who registered on the site and their ratings. The first table is the singer info table, and the primary key of this table is the singer ID. There are lots of attributes in this table, such as birth date or nationality of the singer. They are basically the information that we included in our database about the singer that you can expect to see when you search the singer's name. The second table is the album info, and the primary key of this table is the album ID. If you want to look at the albums released by the singer, you will see information about these attributes. In one album, there can be a song recorded by more than one singer. For example, the song can be a duet, or this album may belong to a group with more than one vocalists, like Pink Floyd. That's why there is a many-to-many relationship between the album info and the singer info tables. One side is mandatory and the other side is optional. An album could include one or many songs, but a song can be released as a single or it can be a part of an album. So the relationship between the album info and our third entity table, which is the song info, is a many-to-many relationship. One side is mandatory, the other side is optional. This is the song info entity table. The primary key of the song info table is the song ID, and the foreign key of this table is album ID. This table includes information about the song. Like I said, singer can include and release the song in an album, or the singer may have also released the song alone without including it on any album. That's why we also made a relationship between the singer info and the song info tables. It is a man-to-many relationship and it is mandatory on both sides. The fourth table is the user table, and the primary key of this table is the user ID. Using the site is completely free, but there will be some features that you can use if you register for the site. Users who want to register on the site will be asked for some information, like user email and user password. From the table, you can see the other informations. The user can search for one or more singers, or the user can just sign up the site and does not search anybody. And a singer can be viewed by 0 users or many users. So the relationship between the singer info and the user table is man-to-many relationship, optional on both sides. The user can search for one or more albums, or the user can just sign up the site and search for nothing. And an album can be viewed by 0 users or many users. So the relationship between the album info and the user table is man-to-many relationship, optional on both sides. Same thing also goes between the user table and the song info tables. This is the user rate table. Users who register on the site can rate the songs. This table shows us which users have rated which songs and how did they rate. The relationship between the song info table and the user rate table is man-to-many relationship, optional on both sides, because a user can rate one or more than one song, or can rate no songs at all, and a song can be rated by 0 or more users. The relationship between the user table and the user rate table is man-to-many relationship, optional on both sides. Users can rate 0 or many times. They can change their ratings, but they can vote the same songs over and over again. For example, user A can rate song B. The user can change their ratings multiple times, but there will be only one data for their rating on that song. The latest vote will count. As for the user rate table, there can be 0 or many ratings. There can be many songs rated by 0 or many users. CSE 204 data table is our primary keys table. You can access the other tables, except the user and the user rate table, from the CSE 204 data table. This table can have one or multiple singer info, album info, and song info tables, but the singer info, album info, and song info tables can be under of only one CSE 204 data table. From here, my teammate Albers will continue the presentation.
Hi, I am Aybars and this is our wireframe for music library. This page is our home page, and in this page we can look to songs, singers, albums, genres by clicking these buttons. User can search anything by using this search button. Then we can pass to login page. User can log in by using this page. If user doesn't have an account, he or she can create an account by pressing sign up button, and the sign up button will be open. Sign up page will be open. When user fill the blanks in this page, our SQL query, this SQL query will be executed. You can see from here. Yes. When we use insert command, normally we write column names, but in this example we gave values one by one. That's why we didn't write column names. And in this example, these data are pulled from user input, and this U6 is automatically given by website. Then when we run this, we will see U6 in here. Next we have songs page. In the songs page, user can see all songs and rates of them. If user log into website already, he or she can rate a song by clicking one of these stars. When user clicks stars, this SQL query will be executed, and here this SQL query. For example, if user rates fun song with 5 points, this data will be added to user rate table here. This will be added to here. And again, user ID U5, which is current user ID, and it's pulled from the website. If user already rated this song, this fun song, insert into will not work. But this update path will run, and the rate of the song, which is given by user, will be updated. And if user didn't log in, he or she can't rate a song, and user will be directed to login page. My friend Bengisu will continue.
Hi, I am Bengisu. Here we are still on songs page. If user wants to change the song name, he or she can click double times to the song name. Then click the change song name button, and the name will be changed in this way. This SQL query will be executed. And we can see changed name here. If user click one of the song's picture or name, this page will open. For example, we clicked Billie Jean song. In the singers page, we can see all singers. If user clicks a singer photo or name, this page will open, and for example, we can see Michael Jackson's informations. If user wants to see all songs of a certain artist, he or she can click See All Songs button. When user clicked it, this SQL query will be executed. For example, we wanted the Michael Jackson song. Here we can see they are in the Thriller album. And also, user can see at this page if user wants to add a new singer, user can click Add a New Singer button. When he or she click this button, user will be directed to this page. And when user fill the blanks in the screen, this SQL query will be executed. At inserting to comment, we did not write all column names because we filled values one by one. For example, Hayko Cepkin, 43, etc. These values are pulling from user input, except singer ID. This singer ID will generate it automatically by system. Here we can see which singer added to the system. Thank you for listening to me. Now my teammate Özgür will continue.
Hello again. This is our albums page. In the album screen, user can see all the albums. If user click one of the album title or album picture, this page will open. And if user wants to remove an album, he or she can click remove album button here. And when user click this button, this SQL query will be executed. Let's see. This query will be executed. Here, album ID will be pulled from the system automatically. It depends on what album you choose to remove. And when we execute this, you can see A10 album was deleted, and all songs in it was also be deleted. You can see there is no A10 album. And when a user removed an album, a user will be notified by this page. And here in this page, user can see all of the genres. If user clicks a genre, this page will open. For example, user, for example, pop genre pop, and songs of pop will be listed in here. And if user wants to see all genres and average rating of each songs in it, user can click this button. And when user click this button, this SQL query will be executed. And when this code executed, as you can see, all songs and their types, genres, will be listed with their average rating. And also user can see it here. That's it for our presentation, and thank you for listening. If you have any question, you can ask. That's it.